Hello again, 7th graders, and welcome back to my YouTube channel. We're going to start by reviewing some of these symbols that we've talked about in the past, and you should know that this, and we talked about this back in 6th grade, this is a symbol that we use to indicate the greatest common divisor or factor. I like to say factor, but the book says divisor, so I should probably write that so it matches your notes, right? Lowest common multiple. Again, the book says least common multiple. It means the same thing. Lowest or least, however you want to write it. So, all right. So if I'm, in that context, this nice little shorthand way of asking what's the greatest common divisor of 4 and 6. And of course, we could list out the factors of 4, factors of 6. Yeah, it's obviously going to be 2. And this is asking for the least common multiple of 4 and 6. And again, if you list them, 4, 8, 12, 16, and then list the multiples of 6, 6, 12, 18. First one in common, of course, is going to be 12. All right. So moving on here, if I ask you to identify these sets as indicated, this is asking for the divisors of 10. Now, there's multiple strategies you should have at your disposal, but whatever the case, you should be coming up with 1, 2, 5, and 10. And the divisors of 25, of course, will be 1, 5, and 25. Now, if I ask for the intersection of those sets, recall that intersection means what values are in both. So that's going to be the set of 1 and 5. Okay. And if I ask for the greatest common factor of 10 and 25, yeah, of course, that's 5. And of course, now when I ask for what's the set of divisors for the greatest common factor of 10 and 25, I mean, this little part right here, it should be clear that this is basically indicating 5, right? And thus I'm asking for the divisor set of 5, which of course is pretty clearly 1 and 5. What do you notice about the sets? You see them? See that? Actually, let me get rid of that dotted line. Now I'll highlight it. Yeah. Seeing the relationship there? So we can make this statement. If D is the greatest common factor of M and N, then the divisor set of D is going to be found by taking the intersection of the divisors of M and the divisors of N. That's our nice little general statement there. So, there's a video here on exercise 37, by the way, that we'll get to in a moment. Actually, I'll have you just watch that on your own if you don't mind. So, here, let me do another example like what I was doing up above. If I'm asking for this, ask for this right here, divisors of the greatest common factor 24 and 40. Well, this particular problem, this can be answered rather simply. Say the divisors of 24. I'll list those out. 1, 2, 3, 4, 6, 8, 12, and 24, like so. And of course, the divisors of 40. I'll spare you the factor tree or factor chimney here, of course. 1, 2, 4, 5, 8, 10, 20, and 40. Now, based on what I just set up here, the divisors of the greatest common factor of M and N, so that is to say the divisors of D here, if you will, just like this, then, quite simply put, it's going to be the intersection of the divisor sets of those two numbers. So let's highlight what's in common. I see 1s are in common, 2s are in common, 4s are in common, 8s are also in common. Thus, I can answer this question here by simply writing the set of 1, 2, 4, and 8. Just like that. So, your assignment for today, obviously, that's the one to watch the video there on exercise 37. But complete exercises 31 to 37 on pages 15 through 17. And a little question for you for an upcoming exercise. Might make a quick note about this. If n is any natural number, then n and n plus 1 are relatively prime. True or false? Relatively prime, by the way, this means have no common prime factors. That's what relatively prime means. Okay? Not that their numbers themselves are prime, although obviously a 7 and 8 are relatively prime. I mean, 7's prime. Of course it is. But the question is, would you ever have consecutive natural numbers, like say 20 and 21? 35 and 36. Will those ever, consecutive numbers, will they ever have common prime factors? Think about that. Be sure to subscribe to my channel, smash that like button, and subscribe. Bye-bye, everybody.